Hello, my name is Saya, and in this video, me and Isari would like to cover a sample question from Chapter 5, Laws of Motion, section for the Newton's second law. So I will be explaining and reading the question, and Isari will be helping me to solve and explain the solution to this problem. So let's get it on. So for the first part of this question, they are asking to state the Newton's second law. We have to make sure to not forget this because a lot of students tend to overlook them during the exam. So basically, the Newton's second law of motion states that when viewed from an inertia reference frame, the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to its mass. And in the algebraic expression, you can express it as sigma force equals to ma mass times acceleration. So after you stated the Newton's second law, let's try out the diagram and the information given. So basically there's a 2 kg block that sits on a smooth, frictionless plane inclined 20 degrees above the horizontal. And that mass is connected by a string to a 5 kg mass that hangs suspended from the other end of the string, as shown in the diagram. And let's try out part A, which they are asking to draw a clear, complete free body diagram showing all the forces of the two masses.
So for the first part of the question, it says draw two free body diagrams for these both two masses. So I will label this as 1 and 2. For free body diagram number 1, it is a 5 kilogram mass which has gravity pulling towards it, and it has a tension which connects to the string. So for the second part, we are going to draw the free body diagram, which is the gravity, which is mg, and also the tension. For the gravity, we have to sort of figure it out for the x component and y component. So for the x component, it's mg sine theta. Also, for the motion, it's common sense that the 2 kilogram will actually flow to this side because 5 kilogram is heavier than 2 kilogram, which shows us the motion is like this. So this is the motion. For this diagram, since it's going over there, it's this side.
So after you had identified the free body diagram for the two masses, let's move on to the next part B. They're asking for the acceleration of the system. In order to find it, you must use the Newton's second law's algebraic expression.
So to recall, the Newton's second law states that F is equals to ma. And for this equation, we know that there are two parts, which is the F component equals to the X component equals to ma, and also the Y component equals to ma depending on the question. So for our first free body diagram, we will be using our second equation, which is Fy is equals to ma. So as we know, the motion is going downwards. So it is mg minus t equals to the force. mg minus t is equals to our ma. So m is 5 kilo and our gravity is 9.8 minus the tension is equals to mass 5, acceleration. 5 times 8 is 49 minus t is equals to 5a. This gives us our first equation. free body diagram, we know the motion is this way since the 5 kilogram is heavier than the 2 kilogram as I said before. So for this we are going to use the first one, which is Fx is equals to ma. Our Fx is, since it's going this way, it's mg sine theta t minus mg sine theta. T minus mg sine theta will give you ma. Theta is 20 degrees from the question, and mg is 2 kilos times with 9.8. You have your T, and M is 2A. This one will give you 6.7, 2A, and this is our second equation. These are the two equations derived from the free body diagrams. Using our math algebra, we are going to solve this. So for the first method, I am going to use equation 1 plus equation 2, which I will be adding 49 minus t with t minus 6.7, and also 5a plus 2a. So here the t gets eliminated. 49 minus 6.7, you will get 42.3 equals to 7a. A will be equals to 6.04 meter squared.
So after you found the acceleration from part B, you can use that acceleration to find the tension in the connected string.
So after you got the acceleration, you can either put it inside equation 1 or 2 to get the answer. So for now, we will be using equation 1. So 49 minus t is equals to 5. Our A is 6.04. So this is 30.2. 49 minus t. When you solve this, t is equals to 18.78 Newton.